Today, guys, we're looking at similarity statements, and we've already talked about these earlier this year as well as over the last couple of days. Um, Today, we're going to try to make this just a little bit clearer. Tomorrow, we're going to work with sort of some maps and everything and look at like scale factor dealing with maps. Well, that's Friday. On Monday, we'll look at kind of some word problems. Then we'll come back to kind of this same concept again with similarity statements when we're working with like sort of perimeter, area, scale factors, things like that. Next Wednesday, we'll review it looks like, and then Thursday, we'll take a test. That Friday, I'm not going to be here. We'll probably have some sort of like algebra review, something like that. Since it is algebra geometry too, we'll probably do something like that. Okay. Today, we're looking at similarity statements. It says be able to write statements of proportionality and verify that figures are similar. So we'll verify that we have similar figures. That's kind of what we're going to look at. So it says use the similarity statement for the triangles to write a ratio of the sides. That's one thing we'll do is write a ratio of the sides in a statement of proportionality. Okay? So given this statement, okay, I kind of rewrote the directions. Here's what you're supposed to be doing. It says decide what sides match up and write a ratio with the vertices in the correct order. Okay? So because of the statement, it doesn't even need to give you a picture at all. Okay? But if it says these two things are similar, this is a very weighty, it's a very meaningful statement. Okay? What it means several things. Okay? One thing it means that angle A is congruent to angle B. Okay? That's what that means. Okay? So I could basically go through here and say that I'm sorry, did I write B? Angle A is congruent to angle D. Okay? That's the first letter and that's the first letter. So angle A and angle D are congruent. It also means that angle B is congruent to which angle? Angle E, because that's the second letter and second letter. And finally, angle C is congruent to angle F. So I could, again, write these on here. There's B it's with E, and here's F with C. Okay? That's one thing that statement means. That's half of it. Okay? The second thing this statement means, because we talked about how the corresponding angles are congruent, it also says the corresponding sides are proportional. What that looks like is that we will write AB in comparison to DE is going to be equal to BC over EF is going to be equal to CA over FD. Okay? So all I'm doing is I'm looking at that statement and I'm able to write this out. Okay? So these are the first two letters and the first two letters. BC and EF are the second two letters. And this last one, CA and FD, are the first and last letter and the first and last letter. Okay? Does that make sense? So whenever you're given one of these, it means all of this. Okay? So if it's a triangle compared to a triangle, if they're similar, it'll give you 6 things back, essentially. Okay? So this is the decide what sides match up. That's this part over here with the ratios and vertices. But also the part with the angles is also important. Okay? How do you know if the figures are similar? How do you ever know if figures are similar? What 2 things do you need? Okay, so corresponding angles are congruent, which is this part here. And secondly, okay, the corresponding sides are proportional. Okay, and that's what this part over here means. Right there. Okay? So those 2 things, corresponding angles are congruent, corresponding sides are proportional. We've discussed that a couple different times. Any questions on the first half of this sheet? Okay. Okay, down below. It says write a statement of proportionality and determine whether or not the figures are similar. Okay, so we're dealing with 2 triangles. What we could do here is we can kind of start comparing these. What's kind of weird is these shapes aren't written in the same orientation, are they? So we kind of have to change our viewpoint. If you wanted, you could maybe like kind of flip this guy over if you want. I know some people do this. I've seen people do this on their paper. They sort of rewrite it so it has the same same orientation, so that makes the T over here, the R over here. It's kind of just redrawing this shape here. Some people do that, some people don't. It just sometimes seems a little bit easier to do that. To write a statement, it looks like we're going to be comparing these, like the 4 and the 2, the 12 and the 6. It looks to me like those are proportional. What we need to do is we need to go through and we need to actually write our statement of proportionality. So a statement of proportionality is basically dealing with the side lengths. Okay? So if we wanted to, we could write, VW is going to be related to which side over here in the small triangle? SR. And I think it's a lot easier to see that with the red triangle than the other one to kind of flip around your perspective. If I was to pick another one like UW, what would that be related to? TR. And that seems to work. And the last one, if I picked like UV, TS, probably, like so. Okay? Now, if this holds, if this has the exact same ratio, we're going to be pretty good. So let's see, which one am I doing? VW, this is V12 over 6. Is that equal to, let's see, UW? Where's UW? We don't know UW. And that would be equal to, let's see, this would be 4 over 2. That does simplify down to 1/2. I'm sorry. I wrote that backwards. 2 over 1. And this appears to be what our scale factor is. But do we have this middle stuff here? Do we have the middle stuff? No. Do we know anything about the angles? No, we don't know anything about the angles either. So do we know if the figures are similar or not? We really don't know. We only know part of this. We know that, it appears like this is going to hold true. With these two sides, it holds true, but who knows what's going on with the other side? Like if all of a sudden I made up some side, like this is, 14, and this turns out to be, like 8, for instance. Is that going to work? No. Okay? So that's kind of the idea that we're looking at, is that we don't necessarily know what it would be. If it was 7, it would probably work. If this was, again, 6, again, that wouldn't work. But if we did know the other side, it would at least give us a good hint at what was going on. The thing is, we don't know those other sides, so there's no way that we can say these are proportional. So I would probably write something like corresponding angles, question mark. We don't know anything about the angles, so I would have to say, no, these aren't similar. We're just lacking a lot of information. Okay? But writing this statement gets us a long way to it. If they were, why don't you guys try this? This is kind of a neat exercise. Why don't you guys try writing a similarity statement? Let's assume that they are proportional. We have the angles and everything else. Try to write a similarity statement. Okay? It'd be really similar to that statement. Let me just circle the one up above. It'd be really similar to this statement right here. Just realize that they're not always in alphabetical order. Why don't you guys take a minute or 10 seconds or whatever you need, try to write the similarity statement for the triangle above. Okay, hopefully that was enough time. The way that I do this, just so you guys know, I start off with whichever one's on the left. I just write that one in alphabetical order. So that's UVW. This is the way that I do it. Yours might not be wrong. Don't change yours yet. I say UVW is similar to, and then basically I just figure out what's associated. So U is related to T. V is related to S, so that has to go next. And then W is related to R, so that has to go last. The way that you can check yours to see if yours is right, because you could have written these in any order you really wanted, the U has to be the same position as the T, the V has to be the same position as the S, and the W has to be the same position as the R. If you wrote something like triangle WUV is similar to triangle, let's see, RTS, is that correct? So let's see, the U and the T need to be the same spot, so that's the middle of the middle. The W and the R need to be the same spot, so that's first. And the V and the, yeah, that's right, okay? So the idea is that there's tons and tons of different ways. There's probably either 3 or 6 different ways that you could actually write this and have the exact same answer, okay? There's a lot of different ways you could have this. So the idea is when you write this, it just needs to be in a specific order. Is that okay? Okay, let's go to the next one. I'm going to add extra information onto the shape just so we can actually do this. I'm going to say these guys are rectangles, and I'll just put little boxes here and all these. They're not squares. Why do you know they're not squares? Yeah, not all the sides are the same, right? I'll also add these on here. I'll say, because they are rectangles, we'll do something like this. I'll say, I don't know how to make 4. Maybe we'll just do that. I don't know, 4. We'll use Roman numerals, I guess, like so. IV. Okay, so we'll just say it like that. So that means that this is 4, this is 3, this is 6 over here, this is 7 up top. Okay? So what are we doing for this one? We need to write, we'll just use the same orientation. We'll write our statement of proportionality. So I'll just start over here somewhere. I'll just say PQ. What's PQ going to be related to? XY. I'll pick the next one. I'll just go around clockwise. What's QR related to? YZ. Let's see, this would be RS. What's it going to be related to? ZW. And finally, let's see, SP. WX. Okay? So there's a statement of proportionality. This kind of gets us to a certain position here. The last thing we need to do, we're just going to make sure that all this makes sense, that it all works out. How long is PQ? 4. How long is XY? 7. How long is QR? 3. How long is, well, it looks like 4, 2. YZ? 6. Then it's probably going to be 4, 7, and 3, 6 again. Are these all equal to each other? No, they're not. These two simplify to 1/2. These are 4/7. Like, that doesn't even simplify. Are these all the same? No, these are not equal. So are these proportional? No. And these shapes they're not similar, right? Okay. Even if the angles are all congruent, even I can come over here and say angle P is congruent to, angle X, and like do all these, right? These two shapes are not similar because this proportion does not hold true. Okay? So actually with this one again, the answer is no. Yes, sir. Nope. They're still not going to equal 1/2 or 2 or whatever. Yeah. Okay. Questions on this? Okay. Your homework's going to be a little bit, it's not going to be exactly what we did. It's going to be close. Okay. I just want to talk about your homework just a little bit. The directions for it say, list all pairs of congruent angles for the figures, then write the ratios of corresponding sides. That's really similar to what we started here. Is given this statement, you're going to write this guy, and you're going to write the ratios of corresponding sides, which looks like this. So for the first 3, that's all you're going to do. Just exactly what we did for, I guess I can call it number 1. Okay? For the next ones, it says write the ratios of corresponding sides in a statement of proportionality, which means this. Okay? Then determine whether the polygons are similar. If they are, write the similarity statement. Okay? So that's kind of like this down here, is that, write this thing, check the information, also check the angles, make sure the angles all work out. If it's true, you're going to write a statement like this. So then there's 4 of them like that. Okay? The last thing, 9 and 10, actually it says, this isn't the last thing. The next thing, it says the polygons are similar as indicated, so it gives you a similarity statement. It says write the ratios of corresponding sides in a statement of proportionality. Then it says find the value of x. Okay, so it's a little bit different. You'll go through and from your similarity statement, the angles are already true. You don't have to worry about them. But write this thing out. Okay? And then you're given some of the information. You have to substitute it in the appropriate places and just use cross multiplication in order to solve for x. It's not really a big deal. The last two, there's only 12 of them on here. It says use the similarity statement to find the scale factor. So again, that would be similar to what we did here, is that if we're given these guys, you write out your statement of proportionality, substitute stuff in, and ideally you'll be able to find what your scale factor is. Okay? So it's not exactly what we did. Just make sure to read the directions carefully. Wherever it says statement of proportionality, that means this giant thing here, right? Whoa, boy. That guy, I guess, right there. Okay? So keep that in mind. If you do have questions on it, you can ask me. You guys do have gobs of time that you guys can work on this in class. Please use your time wisely. I do want you to be in your seats.